That's how you deal with the products of a monomial and a binomial, together with also dealing with a monomial and a trinomial. We all now know and understand what algebraic expressions are. That means we are ready to study products of algebraic expressions. But the big question then becomes, what is a product? A product is a number that is obtained from multiplication of numbers. So if you multiply two numbers, the number that we get, we call that number a product. For instance, if I multiply 4 and 1, I get a 4. This number here, 4, we call it a product because it was a result of multiplying numbers. If I multiply 2 and a 2, I get a 4. The number 4 here is called a product because it was a result of multiplying two numbers. I can even get a product from multiplying 6 and 1 to get a 6. We call the number 6 a product. I can say 3 times 2 is a 6. This 6 is a product because it came about when you multiply two numbers. We are going to do exactly the same. Remember that with algebra, we study numbers in a general form using symbols and letters. Now we're going to do that for algebraic expressions. We're going to find products of algebraic expressions. We use a law called the distributive law to do products of algebraic expressions. This law says that if you have a monomial A, remember it's one term, multiplied by a binomial B and B, remember that we have two terms here, and this becomes a binomial, right? Because they are multiplying each other, remember that brackets in mathematics means multiplication. Because this monomial is multiplying this binomial, the answer that we're going to get here is going to be called a product. Hence, we say we're doing products of algebraic expressions. Now, the distributive law says that, before maybe I can talk about that law, let me just share a little bit of what the word distributive means. This word actually means to share. So this law says that if you have algebraic expressions or an algebraic expression that are multiplying each other, the terms must be shared. So the A here must multiply the B, and it also must multiply the C. It has to be shared between A and B. It has to spread. Another way of understanding a distribution or distribute is that you spread, right? It has to be spread between A and B. A and B and C, I meant to say. So now we're sharing this A with B and we're also sharing it with C. Obviously, brackets means multiplication. If we say A times B, we're simply just going to get AB. Then if we say A times C, we're simply going to get AC. That is the rule that we are going to use. Now, to practice this, we're going to do this through a series of examples where we apply this distributive law. The first example will focus on multiplying a monomial by a binomial, and also we'll have a collection of examples where we multiply a monomial by a trinomial. right? If you want to understand what these terms mean, please check the previous lesson, part 1 of this lesson. So here I'm going to say we are doing example 1, and the example reads as follows. It says simplify the following fully. Now, just to break what this problem is asking us, you would notice that when we multiply here the a with a b and the a with a c, we are actually expanding this expression. Remember, we said this is an expression. We are expanding it so that it is ab plus ac. It is now expanded, and at this stage there's nothing more we can do. It is simplified. It is in the simplest form, right? It is simplified. So we say that we were solving this algebraic expression so that it gets to be simplified. So basically, when they say here simplify the following, each of these questions that they've given us fully, they're actually saying we should expand them so that they cannot be solved any longer, right? So the first one that we are given, 1.1, we are given here in 1.1 4 times x plus y, 4 times x plus y. Our law of distribution says that we should distribute the 4 here on the x and distribute it to the x or to the y. We should share it with x and y. And absolutely, when we say 4 times x is going to be a 4x. When you say 4 times a y is going to be plus 4y. Now, this y, this positive here, we keep it as it is. It comes down as it is. At this stage, there's nothing more we can do. We cannot combine these two. They're different. They are unlike terms. You can't combine them. They're not the same. So that means it is simplified. The second question, 1.2, it has negative 2 times 4x minus 3. 1.2, we have negative 2, 4x minus 3y. The same rule says here to us that we must distribute the negative 2 to the 4x, right? By doing that, we will have negative 2 times a 4. This will give me a negative 8, and we keep the x as it is here. Then we have a negative 2 times a negative 3. That should give me a positive 6. And we keep the y as it is there. Now, usually we can rearrange this so that it starts with a positive number. We can take this positive 6x and put it in front, and take the negative 8y and put it this side. We call this commutative property of addition, right? Numbers are commutative. In other words, if I add a 2 and a 3, it is the same as adding a 3 and a 2. I'll get the same number here, which is going to be a 5, right? So that's why I can rearrange this, right? They are commutative. We're going to go to question 1.3, which says 5b times b plus b. 5b times b plus a 5, right? Again, we're going to apply our distributive law that says you distribute the 5b there so that it is 5. But now look at this. What is going to happen here is that we are going to have a b times a b. A b times a b, it is the same as remember that this is the same as having invisible 1 and having invisible 1. Our laws of exponents from grade 9 say that we keep the base, we add the exponents. So that now I'm going to have 5b to the power 1 plus 1, which is 2. This is going to be b squared. So this means here we're going to have a b squared. Right? Now, we then going to distribute again the 5b to the 5 there. A 5 times a 5, it should give us a 25. So we're going to have the plus as it is, and we're going to have a 25b. So remember that we still have this b here. It will also come there when we multiply. Right? I hope that one was clear. Then we go to 1.4. 1.4. It says 8 times y squared minus 2, right? So we have here an 8 multiplied by y squared minus a 2. This will give us, when we apply our distributive law, right, we're going to multiply the 8 and the y squared, which will simply be equals to 8y squared. And when we distribute or share the 8 with the 2, is going to be 8 times negative 2, right? And this will then give us here a negative 16, right? Because 8 times 2 is a 16, right? Then we also have 1.5 that says we have a 2x times x, and we then have 5y minus 6z, right? So we have a plus 5y minus a 6z. Now, if you look at these problems 1, 2, 4, they were actually a product. Remember the answers that we get here when we multiply these two. They were a product of a monomial and a binomial, because I was multiplying a term multiplied by two terms, right? So this answer here is what we call a product, right? Because it's a result of multiplication. It's what we got when we multiplied these two terms. But when we get at this stage, it's actually has changed. We have a monomial times a trinomial. It means now we are doing a monomial multiplied by a trinomial, right? So let's do that multiplication in the same sense that we did with binomials, a monomial and binomial. We are going to multiply each term here by the 2x, right? The first one would be the 2. Remember that this would then mean that I'm going to have an x times an x, right? So this means I'm going to have here x multiplied by x. This means I'm going to keep the base and add the exponents, and that should give me a 2 there, having x squared, because remember here I have invisible ones. I keep the base and add the exponents. So this means here I'm going to have 2x squared. The next one is going to be a 2 times a 5, right, which is simply going to be a 10. Remember that we are distributing this now here with the positive there, and the x and y would be just x times y. Remember in mathematics that space means multiplication. This space here means multiplication. So the 10 is multiplying the x and multiplying the y as well. Now we are going to distribute this to the last term here, right? So we're going to say 2x times 6z. A 2 times a 6 should give us a 12, and we're going to have x and z as they are, right? Now we jump to 1.6. 1.6, we are given here that we have 7y times xy minus 2y plus 4x minus 2y plus a 4x. Now again, we're going to apply our distributive law that says I'm going to multiply 7y and xy. Now with this one, I'm going to have the 7x, but my y, this y and this y, there will be y times y, which is going to be y. Remember, this is to the power 1 plus 1 here, because I keep the base and add the exponents, and I'll end up having 2 y to the power 2. So it means here I'm going to have 7x y to the power 2. Then we are also going to distribute the 7y to the 2x, and this will give me negative 14, right? Because the 7 times a 2 is a 14, but again the y we know is going to give us a y squared, because again we're having here y times y, which will end up giving us a y squared. Now the last term that we're going to multiply would be a 7y multiplied by a 4x. We're going to have a plus, this is going to be 28, right? Because 14 and 14, 28, yes. And then we're going to have xy. The x and the y will just multiply each other like that, because they can't combine. They are not the same. If we jump to question 1.7, it says here that we have a times a squared times 12a, and we also have the 7ab minus b, right? So we're going to have plus 7ab minus the b. Now with this problem, again we're going to do our distributive law, where we say a squared times 12, right? Remember that here we have an invisible 1. That's why here when we say 1 times 1, when we say 1 times 12, it gives us the 12, right? But here we're going to say a squared times the a, right? Now this will give me a squared times the a. It means I keep the base. Remember here I have invisible 1 and add the exponents. So I'm going to have 2 plus 1, which is going to be a to the power 3, right? So it means here I'm going to have a to the power 3, right? Guys, if you need to revise your laws of exponents, please do so. We will revisit the laws of exponents in grade 10 and add more of the laws and some nice problems as well. But you should be able to know these basic laws when you solve algebra, or when we deal with algebra, right? We are going to distribute the a squared again to the 7ab, where we are now going to get a 7, because this 7 here will multiply with the invisible 1 there, but the a will multiply with the a as well, and again we said it will give us an a to the power 3, right? And the b there will just be a b, because it just multiplies with the invisible 1 again there at the back, or you can say they're multiplying as three numbers like that. We then add the last term here, have a squared times b squared, which is going to be times minus b squared actually, which is going to be minus a squared times b, right? And that's how that question will end. At this stage is solved. There's nothing much you can do, right? So we say it is simplified. It is in its simplest form. I know it looks long and complicated, but the idea is that we cannot solve it any further. That's why we say it's simplified. It is solved. 1.8, we have 2x squared, 2x squared, and we have x squared here, and we have negative 3x plus and 8 there, right? Now again, we're going to use our distributive law that says 2, we're going to multiply 2 with an invisible 1 here, so that we have a 2 here. But now when you multiply the x and the x squared, you are now going to have x times x squared. This means I keep the base and add the exponents, because remember we have invisible 1 here, so that now I have x to the power 3. It becomes x cubed. So this will be 2x cubed, right? And we're going to multiply this term here with a negative 3x. The 2 and the 3 will give me a negative 6, and by now we should see the pattern. The x and the x would be an x squared. I hope you are now able to see that, because I've been doing this type of multiplication between the x and the x and the a to give me a squared. I hope now you are able to see it. And lastly, we have to multiply 2x with an 8, right? The 2 and the 8, they will give me a 16, and the x will just sit there with it. And then we have 1.9, where we are dealing with x times x squared minus 2x plus 4 minus 2x plus 4, right? And again, with this one, we're going to multiply the x and the x squared. It should give me x cubed. And we're going to multiply the x and the minus 2x. It should give me a negative 2x squared. And we're going to multiply the x and the 4. It's simply going to give me 4x. Then we have the last question there, 1.10. It looks complicated. That's an interesting one, right? We have here 1 over 3 q, 1 over 3q, and we have 1 over 25 p squared. Okay, we have a p squared here. Negative 1 over 15 pq, negative 1 over 15 pq, and we have plus 1 over 9 q squared, plus 1 over 9, and we have a q squared there, and close bracket. Now let's have a look at this. So sometimes expressions can come as fractions. You have to also be comfortable working with fractions. Again, you need to remember how to deal with fractions the way you did in grade 9. Now at this stage, we're going to apply our distributive law that says we're going to multiply this with that, right? This monomial with the first term in the brackets there. So we know that our rules of fractions is that the 1 will multiply the 1, so that I have 1 here, but the denominator will multiply with the denominator 3 times 5. You should be able to get a 75 here, and the q and the p will just be the way they are. We'll have a p q. So oftentimes we arrange this alphabetically, right? But it doesn't matter even if you can start with a q like that and write a p like that, because we know that multiplication is associative, right? If you say 2 times a 3, it is the same as 3 times a 2. They both give you a 6, so it doesn't matter. The order doesn't matter. It's just that it is customary that we arrange them alphabetically. It's just the thing that we do in mathematics. Now we're going to take this term and multiply it with a negative 1 over 15pq. Now here again, the 1 will multiply the 1 there, so that I have negative 1, and the 3 will multiply the 15 there. That should give me a 45, and the p will be the way it is, but the q will be a q squared. Remember that we are multiplying q and a q here, and we know that this will give us a q squared. Now we are going to multiply this term again, 1 over 3q, with 1 over 9q squared. Now this would give me a positive because they are both positive. The 1 and the 1 at the top there would give me a 1, but 3 times 9, we all know that that is 27. So that now I have a q to the power 3. How do I get to that? I'm going to say q times q squared, right? This q times the q squared. But now here, I'm going to keep the base and add the exponents. My base are the same, q and q. Remember, there's invisible 1 there. And when I add these two, they actually will give me a 3. That's how I end up with a cube there. And when you look at this, there isn't much that you can do. These are not like terms. You can't add them. You see, this is a p squared, right? And this is a q squared, right? So you can't add this. So there are different terms. So this is simplified. There isn't much that you can do.